안녕하십니까. 웹스시스템코리아 기술지원부입니다. 저는 구조해석 담당하고 있는 아코 과장입니다. 본 영상은 영문으로 작성하였습니다. 한글 내용은 자막으로 참조 부탁드리겠습니다. Greetings and welcome to the 웹스시스템코리아 channel. In this video, lab joint model is taken as the first example. Using this example, we will be looking into the capabilities of 3DEXPERIENCE SIMULIAworks. SIMULIAworks is a very powerful platform to perform highly innovative structural simulations. This is the lab joint model. It has two plates which are connected in the middle by a rivet. This first example model will be discussed in few series. Into this first series, we will be talking about the meshing capabilities in SIMULIAworks. In the second video of this first example, I'll be talking about the pre-processing and the simulation process in SIMULIAworks. This is the boundary conditions of this model. One end is fixed and a symmetrical boundary condition is applied, and the load is applied at the other end of the lab joint model, and the load is applied as displacement. And finally, in the third video, I will present the post-processing and make conclusions of this example. The model you see on my screen is the lab joint model. There are two plates, and these two plates are connected by a rivet in the middle. These two plates belong to the same model, and the whole model has been prepared into half, which is symmetric in the middle. I have imported the whole model into the 3DEXPERIENCE platform. After selecting the part, I will activate the structural model creation so that I can start creating finite element model. I will create the FEA model from the scratch, so I will choose none and proceed. Now, a finite element model has been created, and I'm going to rename it to make it more organized. After double-clicking on the nodes and elements, I can access to the meshing tools. This plate structure is simple, and hexa element can be applied easily. When I select the plate model, the model is changed to yellow color, which indicates that the model is eligible for the hexa element. Since the mesh is very fine, I will double the element size. And now it looks okay to proceed. As I have mentioned before, the two plates belong to the same model, so when one of the plate models are meshed, the same finite element definition will be applied to the other model as well. Now the two plates are ready, and I need to define finite element model for the rivet as well in the same manner. After double clicking the rivet model, activate the structural model creation app, and again choose none to create the mesh from an empty FEA model. I rename the finite element model to make it neat and organized. The rivet model looks simple to apply hexa element, but when I select the rivet model in the hexa meshing process, the color is changed to dark orange. It indicates that the selected rivet model is not eligible for hexa element. When I mesh it, tetrahedral element is applied instead. The system algorithm applies the optimized element type according to the model boundaries. In this rivet model, tetrahedral element is the best element selected by the system. Now the whole model has been meshed and it is ready for simulation. But there are many reasons that tetrahedral element is not recommended to use, and I will show how to apply the hexa element to this rivet model. First, I will delete the existing mesh model. I need to split or partition this rivet model into smaller chunks so that the algorithm can find a way to apply hexa element. The CAD model was created in the SOLIDWORKS, and the model cannot be partitioned directly since the platform does not read the SOLIDWORKS file directly. Therefore, I need to insert volume first before I start the partition job. Since the volume is available to partition, it is ready for the platform to split the rivet model. There are many ways to split the body, using faces, planes, and so on. I will use the cylindrical face to split. Please remember that more features are available to add more parameters to make the partition job easier and efficient. And now, I will use the rivet flange head surface to split further. This partition job is kind of similar with the one found in Abaqus. And finally, other end is also partitioned in the same way. Since the partition job is done, let's go back to the meshing tools. By just looking into the partition model, it will be easier to apply hexa element as compared to the previous one. When I select the part, now the part color is changed to yellow and hexa element is applied easily. In this way, partition tool is very useful to implement hexa element in the model. It does not mean that this method will be always possible to any type of model. There will be difficulties to implement hexa element even after using partition tool. After some more extra work, I have created few more local planes. Local planes are very useful to partition any volume, and these planes can be created easily in the 3DEXPERIENCE platform. I have partitioned the model further, and this is the final one. And this is the final mesh model. There are many features and capabilities of meshing, and I will be talking more on meshing from time to time in the future videos. This concludes my first video on this first example. Please stay tuned with us and I will see you on the next video. 이번 영상은 여기까지입니다. 문의사항 있으시면 웹스시스템코리아에 연락 부탁드리겠습니다. 다음 영상에 다시 인사드리도록 하겠습니다. 감사합니다.